You walk into the kitchen at midnight, flick on the light, and catch a blur of brown darting under the fridge. That blur is Periplaneta americana, the common American cockroach. We largely know them as deeply unwelcome roommates, notorious scavengers that contaminate food and act as vectors for several diseases. Freezing this frame reveals the mechanical complexity of the insect, a biological machine refined for high-stakes survival. Looking at this diagram, the insect's body is segmented into 3 distinct regions: the head, the thorax, and the abdomen. The exterior is encased in a brown exoskeleton of hardened plates called Sclerites, connected by thin, flexible membranes. This combination of hardened plates and flexible joints gives the insect maximum protection without sacrificing speed. It's the primary physical defense for a creature that spends its life navigating tight, dark spaces. Once the lights go out, that insect emerges from its crevice to search for calories. Navigating a pitch-black kitchen requires a specific set of tools. Long, thread-like antennae sweep the space ahead of the insect. These are packed with sensory receptors that actively monitor changes in the immediate environment, feeling out obstacles and chemical trails. This illustrates the compound eyes. Each eye features roughly 2,000 individual hexagonal lenses called ommatidia. Working together, these produce Mosaic vision. Capturing light across thousands of points simultaneously, it absorbs massive visual data in the dark, trading sharp details for extreme motion sensitivity. When those sensors locate a dropped crumb, the insect goes to work. The mouthparts are explicitly built for biting and chewing, featuring a pair of sharp mandibles and a flexible lobe called the hypopharynx, which acts like a tongue to manipulate food. This cross-section shows the internal alimentary canal. Swallowed food moves through the foregut into a storage sac called the crop. Next is the gizzard. Operating as an internal mill, it uses 6 chitinous plates acting as teeth to physically grind large food particles down. Pairing a highly sensitive visual and tactile network with an internal physical grinder allows the roach to rapidly locate, consume, and process almost any organic scrap left behind. A scavenger out in the open is exposed. If a human drops a shoe, the roach executes a near-instantaneous dodge. Reacting in fractions of a second requires a specific neurological architecture. Instead of waiting for signals to travel to a central brain and back down, the insect relies on a decentralized nervous system. The nervous system is spread along the ventral side as fused ganglia, 3 in the thorax, 6 in the abdomen. Because motor control and processing happen locally, a headless insect can still function and react for a week. Fueling these rapid reflex-driven movements requires efficient internal plumbing. Cockroaches utilize an open circulatory system. Instead of closed veins, the internal visceral organs are directly bathed in a blood-like fluid called hemolymph. This model illustrates their respiratory system. They don't have lungs. Instead, air enters through 10 pairs of small lateral holes called spiracles, then travels through a network of branching tracheal tubes to deliver oxygen directly to the tissues. Meanwhile, a series of filamentous Malpighian tubules actively filters the hemolymph, pulling out nitrogenous waste and converting it into solid uric acid to conserve water. A body that processes threats locally, breathes directly into its tissues, and aggressively recycles water is built to outrun and outlast external threats. Having dodged the shoe and vanished into a dark crevice beneath the baseboards, the insect's biological priorities shift from individual survival to species propagation. Looking at the female reproductive system, you can see 2 large ovaries containing chains of developing ova. Once fertilized, these eggs are deposited into a specialized genital chamber to be encased. The female produces a tough, dark reddish-brown capsule known as an ootheca. Each of these hard-shelled protective cases holds 14 to 16 individual eggs. She then strategically glues the capsule onto a hidden surface, usually inside a tight, highly humid crack right next to an active food source. Cockroaches follow a parometabolous development cycle, meaning they develop through a nymphal stage. The eggs hatch into small, wingless nymphs that look nearly identical to the adults. They will grow and shed their exoskeletons roughly 13 times before reaching full maturity. Because a single female can drop up to 10 of these capsules over her lifespan, spotting just 1 insect darting across your floor is a reliable mathematical indicator that dozens more are developing inside the walls. By morning, the kitchen is quiet. The homeowner makes coffee, unaware of the complex biological machinery resting silently behind the plaster, waiting for the sun to go down. We see them as pests, but they operate utilizing an intricate toolkit. They wear flexible armor, navigate via a hypersensitive mosaic optical grid, and grind down their meals with internal chitinous teeth. They process threats through a localized nerve network that doesn't even require a brain to trigger an escape, and they pump air directly into their tissues. While they remain a persistent public health hazard, the cockroach possesses a body strictly refined for endurance, one that has occupied the margins of the human world for millennia.